We'll have a look at histograms to finish with. Again, these are something you will have seen before. They're another way of representing data. It's quite useful when we've got data that's split into different groups, so we quite often get that with height or weight, anything where the data is split off into several sections, or age is split into categories as well often. This is the thing that kind of defines histograms. The area of the bar represents the frequency. Okay, so it's not just how tall the bar is, like in a bar graph, it's also about how wide the bar is, and it's the total area, which tells us about how many people are in that group, the frequency. So here's an example to look at. I've got a table of data and a histogram, and these are both representing the same data. Okay, so this first row in the column, this first row in the table is for people who have a weight between 60 and 65 kilos, and there's 20 people there. If we have a look at the corresponding bar on the histogram, it's this one here. Now the width of that bar is 5, yes, 65 minus 60. The height of it is 4. Yeah, so the height of it is 4, as you can see here. If I do 5 times 4, I get 20. I get a frequency of 20, just like I did in the table. As I say, this histogram and the table are the same data, so I'm just showing you how you can kind of convert a table into a histogram, or a histogram into a table more commonly. If we have a look at the second group, just to show you again, the 65 to 70 category is this one here. The width of that is 5. The height of it is 5. That gives us a frequency of 25, which matches with the table. And you'll find the bottom two do as well. Have a go at that yourself and just check they do match. But they will do. The important bit is to remember that it's the area of the bar, not just the height of it. So, for instance, this third bar, although it's not as tall as the first and second bars, it's much wider. And actually, the frequency you can see from the table is higher. So it's about the area, not just the height. So an added complication to histograms that comes up in AS, in your A-level maths, is that the area is just proportional to the frequency. It doesn't necessarily match up one-to-one like the previous histogram did. I'll try and explain that to you now. If you have a look at this first row, this is the 60 to 65 kilograms. I've just changed it round a little bit. Now, the width on the histogram on that bar is 5, and the height is 4, which gives me 20 units of area. Now, the frequency in the table says 60, which seems like it doesn't match up, but it's because there's a scale factor been applied here. Remember, the area is just proportional to the frequency. It's not necessarily exactly the same. What we can see here is because the area is 20 and the frequency is 60, we know that 1 unit of area is actually 3 people. Okay? Because I've got 20 units of area and they match up to 60 people in the table. So I know that each unit of area must be 3 people, because 20 times 3 gives us the 60. Let's have a look at this second column and see if we can work out what this question mark is in the second row. So 65 to 70, let's have a look in the histogram. It's got a width of 5 and a height of 5, which is 25. So I've got 25 units of area. But if I look at my conversion factor up here, I know that each unit of area is worth 3 people. If I've got 25 units of area, that must be 75 people. Okay, that'll be the second column. The third one's filled in, but let's have a look anyway, just to make sure it matches. So in this 70 to 80 bar, it's got a width of 10 and a height of 3, which is 30. Each unit of area is 3 people, so an area of 30 is actually 90 people, which matches up with the table. And let's figure out this last one. So 80 to 90, width is 10, height is 2. That's 20 units of area. Each unit of area is 3 people. So I know that one must represent 60 people. Okay, so hopefully that made sense. I'm just showing you that the area of the histogram and the frequency it represents don't necessarily match up. It's just proportional to each other. Sometimes we need to find that scale factor. And I've got one more example for you on that. So this one is on water intake. So it's how much it's a piece of data about how much water people drink per day. Now I've only given you one filled in row in the table. Okay, this first one. I said the people who drink between 1 and 1.25 litres a day of water, there's 25 people. If I have a look at the first bar here, the width of that bar is 250. The height is 0.02 on the frequency density column. Sorry, I haven't mentioned that this y-axis, we call it frequency density. Okay, it's not the frequency, the area of it represents or is proportional to the frequency. This y-axis is called the frequency density. Probably have seen that before at GCSE. If I do this sum, I get 5. Okay, now I know that has to equate to 25 people. So an area of 5 must represent 25 people. And that tells me that each unit of area is 5 people, yeah? Because if I have 5 units of area, that would then give me 25 people, which matches with the table over here. Now I've got that conversion factor, I can work out all the rest. So let's have a look at this second bar. It's got a width of 250 again, so these are the people that drink between 1,250 and 1,500 milliliters of water a day. It's got a height of 0.04, and that gives us 10 units of area, 5 people in each unit of area, so there must be 50 people. The third bar, it's got a width of 500, height of 0.06. That gives us 30 units of area, 5 people for each unit of area, so that must be 150 people. There's 2 to 3 litres, so people drink quite a lot of water per day. That is 1,000 times 0.02, which is an area of 20. Times that by 5, because there's 5 people for each unit of area. There's 100 people there. And there's 3 to 4 litres, people who drink a serious amount of water a day, so maybe these are athletes, people who do lots of exercise. We've got 1,000 for the width, 0.01 for the height, so that's an area of 10. 5 people for each unit of area, so there's 50 people in that category. Okay, so that gives you an idea of how to figure out areas from histograms and how to turn histograms into tables of data, and also the other way around. That's the key bit, is being able to move between those two types of data and being able to actually interpret histograms.